Good morning to all of, good afternoon all of you. Myself, Professor N. Adpe from SNT College of Engineering and Research Center, Yevla. Now today we are discussing uh, the new topic regarding numerical methods and computer programming. That is your numerical integration. The numerical integration. What is integration? The integration which is required to find the area under the curve, which is not desired area like circular area, rectangular, uh, triangular, like that. Suppose there is some random area, then the area under this curve can be find out by using numerical integration. In that, there are three methods for finding the numerical integration. First, trapezoidal rule. Second, Simpson's 1 by third rule. Third one is Simpson's 3 by 8 rule. Now, today we are discussing the topic topic that is trapezoidal rule for integration. Then what is integration? The process of measuring the area under a function plotted on a graph. That is uh, integration from integration of a to b f of x dx. There is some area is given, that is point A and B on x-axis and y on y-axis. There is a curve where f of x is the integrand, a is lower limit and b is your upper limit of integration. Means the lower limit a and upper limit is b. In between that there is we can find the area. The basic of trapezoidal rule, that is this is based on, this rule can be based on Newton's code formula that states if one can approximate the integrand as a nth order polynomial, that is your I is equal to integration of a to b f of x dx, where f of x is not equal to fn of x, and fn of x, this is your a0 plus a1 x plus a2 x square plus dash 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 a n minus 1 x raised to n minus 1 plus a n x raised to n. Like uh, this formula we can also taken from the Newton's forward difference interpolation method. Then the integral of that function is approximated by the integral of that nth order polynomial, that is a to b f of x is not equal to or is equal, nearly equal to integration of a to b fn of x. Trapezoidal rule assumes n is equal to 1. That is the area under the linear polynomial. Means there is only one step is used for finding the area of the curve by using trapezoidal method. But in Simpson's 1 by third and Simpson's 3 by 8 rule, there are two steps and there are three steps are considered individually. Then n is equal to 1. Then integration of a to b f of x dx is equal to b minus a f of a plus f of b upon 2. B minus a, it is your step size. Step size from a to b. Suppose there are number of steps are given. Suppose all the step size are equally distributed, then we can write here b minus a, instead of b minus a we can write the h, and h is nothing but your step size. Suppose the step size are different, then we can write b minus a, the difference between the x value. The derivation of that method is the method, the area under the curve is a trapezoid, the integration of a to b f of x dx is nearly equal to area of trapezoid. It is equal to 1 by 2 into sum of parallel sides into height. Height means or your the difference between the two limits, difference between the limit, upper limit and lower limit. 1 by 2 into f of b plus f of a into b minus a. B minus a is nothing but your step size. Then we can write b minus a divided by 2 into f of a plus f of b. Similarly, for next step, suppose there is a one example. The vertical distance covered by a rocket from t is equal to 8 to t is equal to 30 seconds is given by x is equal to integration of 8 to 30 2000 log natural 140000 divided by 140000 minus 2100t minus 9.8 t dt. Use single segment trapezoidal rule to find the distance covered, find the error and find the relative error. Suppose for finding the area under this curve, the formula is I is equal to b minus a f of a plus f of b divided by 2. And the value of a is 8 and b is equal to 30. Then f of t is equal to 2000 log natural 4 times 0 divided by 4 times 0 minus 2100t minus 9.8. Then we can find the value of function at t a is equal to 8 and b is equal to 30. Means f of a and f of b. Means the f of a we can put the value of value 8 instead of t and find the f of 8, and also put the value of t as a 30 and find the value. This is your 177.27 meter per second, 901.67 meter per second, and put these values in that equation. I is equal to b minus a f of a plus f of b divided by 2. The 30 minus 8 into 177.27 plus 901.67 divided by 2. Then this is your the distance which is covered by that rocket, that is 11,868. The exact value of above integral is we can find by using numerical direct derivation or by solving integration. Then the exact value is 11061. Then the error is 11061 minus 11868. That is your minus 807 meter. This is your error which is found in the calculation. The absolute error or relative error. Relative error means the error divided by actual value. Error divided by actual value into 100. This is your percentage relative error, that is 7.2959%. This is the method for finding the integration of any graph by using trapezoidal. Suppose in example 1, the true error using single segment trapezoidal rule was large. We can divide the interval, that is 8 to 30 into 8 to 19 and 19 to 30 intervals, and apply trapezoidal over each segment. In that method, we can divide the total interval into two sections, that is 8 to 19 and 19 to 30. In that there are two formulas. First one is I1 plus I2. This is your by finding this value, this is your I1, this is your I2, and the addition of that, this is your total integration. Then find by using this formula f of 8, f of 30 and f of 19. Put all the values in that equation and find the values. Then the relative error is less. That is the true error is minus 205 meter. Means the error can be minimized by dividing the steps, by dividing the interval into number of step size. Number of step size. Then we can reduce the error and uh, find the solution which is near to the actual solution. Which is near to the actual solution by using trapezoidal rule. This is this is again the one method, one numerical, that is the the total the total limit, upper limit and lower limit, which is divided into number of four parts. Divided into four parts means the step size is the number of steps are increases. The step size are equally distributed. Then we can derive by a to a plus h, a to a plus h to a plus 2h, a plus n minus 2h to a plus n minus 1. Means the range will be divided into n number of steps, n number of steps. Then by using that we can find the integration, that is n is equal to, suppose in that segment b minus a upon 2n into f of a plus 2 into f of a plus is plus f of a. This is your formula. Suppose the number of steps are increases, then the formula, this is the y, the value of function at lower limit plus value of function at upper limit plus 2 into remaining terms of functions, and it is your b h, that is your step size divided by 2, divided by 2. This is your total this is your formula for finding the integration by using number of step size, when the number of step size are increases. Then the solution is 11,266 by finding that. Then the relative error should be minimized and true error should also minimize. This is your again third example is the use multiple segment trapezoidal rule to find the area under the curve. The function is 300x upon 1 plus e raised to x from x is equal to 0 to x is equal to 10. Suppose h is equal to 5. Suppose only one 10 minus 0 upon 2. Suppose n is equal to 2. Number of steps to the suppose we have taken the number of steps are 2, then the step size is equal to 5. Then the number of interval, that is 0, 5 and 10. Then we can find the f of 0, f of 5 and f of 10 by putting the values of x in the functions. Then f of 0 is equal to 0, f of 5 is equal to 10.039, f of 10 is equal to 0.136. Put the values in that equation. B minus a divided by 2 into n into f of a plus 2 into remaining term plus f of p. A plus ih means 0 plus 5. F of 0 is 0 plus f of 5, 2 into f of 5, 2 into 10.039 plus 0.136. 0.136. Then we can find this value, that is your the area under this curve 50.535. 50.535. This is your this is the method for trapezoidal method for finding the integration or to find the area under the curve by using trapezoidal method with a number of steps and equally step size or different step size. Okay, this is a okay. So thank you for listening.